In the last lesson, we saw how a plain, insecure email exchange between Alice and Bob is pretty much accessible to anyone on the same network, as demonstrated by having Eve sniff the network with Wireshark and finding the SMTP package containing the email in plain text and as such readily available to read. In this lesson, the first layer of security now added to the so far insecure emails is to have Alice digitally sign the email with the signing certificate she obtained from the issuing CA1. In order for this to work, both Alice and Bob must trust the same root CA that sits at the top of our PKI, and the way to seed this trust in systems, such as the email system we use in this demonstration, is by putting the self-signed certificate of the root CA into the trust store of the Thunderbird email system. The trust store in Thunderbird is found under the Thunderbird preferences, and looking at the certificate manager of Thunderbird, it's clear that a default installation of Thunderbird is already shipped with a few hundred certificates of various X.509 authorities that the default installation of Thunderbird then explicitly trusts. Adding the root CA of our own custom X.509 PKI is then quite simple by just importing the root CA certificate and to confirm to Thunderbird that the root CA should be trusted for the identification of mail users, which is our use case presented in this demonstration. With having the root CA added to the trust store of Thunderbird on both Alice's and Bob's machines, both Alice and Bob now have the initial seed of trust into our custom PKI. This is sufficient for the setup of Bob, but in order for Alice to now being able to sign her email to Bob, Alice needs to also add her signing certificate to Thunderbird together with the certificate of the issuing CA1 that issued her signing certificate. Adding the certificate of the issuing CA1 to the trust store of Thunderbird is exactly the same as adding the certificate of the root CA, and again requires Alice to confirm to Thunderbird that the issuing CA1 can be trusted to identify mail users. Adding her signing certificate to Thunderbird is then under your Certificates tab of the Certificate Manager, and what we really need to provide Thunderbird with here is not just a certificate, but also the corresponding private key, and Thunderbird expects this combination of the certificate with the corresponding private key to be provided as a password-protected PFX container. PFX containers I have covered in the previous chapter, and combining an existing certificate with its private key, if provided in two separate files, is simple to do with OpenSSL, which I have done beforehand, and the resulting PFX container for Alice's signing certificate and signing key then made readily available on her desktop. Once the signing key of Alice is imported into her Thunderbird, Alice then needs to specify that this certificate should be used by Thunderbird to sign her emails. In Thunderbird, this is done in the account settings, where under the section Security, the proper signing certificate can be selected. Once selecting a signing certificate, Thunderbird asks whether also an encryption certificate should be installed. For this lesson, I declined this offer, as the encryption of emails is the subject of the following lesson. Having selected the signing certificate for Alice, Alice is then finally good to go to write another email to Bob, where before sending the email, Alice has to tick that this email now indeed should be signed, and once Alice ticked this, the email can be sent. Bob is then happy to receive another email from Alice, and once Bob opens this email in Thunderbird, Thunderbird now marks the email from Alice with an icon of a nice sealed envelope. Clicking on this envelope then gives a message indicating that Thunderbird detected a valid digital signature on this message with Alice as the signer, and that this allows to conclude that the email has not been altered since it was sent by Alice. That's cool, as with the insecure email that we started off with, nothing would have prevented Eve from not just sniffing the network, but additionally also to intercept the email sent by Alice and to modify the email according to her own will, and with Bob then not having any means to detect that the email he received wasn't the original message sent by Alice. Although cool, Thunderbird also clearly states that the email itself was not encrypted, but this will be dealt with in the next lesson. Having the signed email exchange between Alice and Bob, let's have a look at what Eve managed to see. Again, filtering the Wireshark package for SMTP packages, the SMTP package corresponding to the signed email of Alice can be easily found. Looking into this SMTP package, the starting fields of the internet message formats are still the same as for the completely insecure email sent in the previous lesson, and it's clear that this was an email from Alice to Bob with the subject just defined by Alice on her email. The first interesting difference to the insecure email sent in the previous lesson now is with the declared content type. The content type of this email is now a signed and multipart S-MIME email, and this S-MIME multipart content can then be drilled down in Wireshark. The first part of this multi-part content is then just the text-based body of the email, and which demonstrates that digital signatures do not provide any confidentiality to the emails exchanged, as the content of the email, although wrapped into a multi-part container, is still transmitted as a plain text over the network. The second part of this multi-part content is then the digital signature calculated for the content in the first part of the multi-part message, and with this digital signature, of course, being calculated with the private key of Alice that corresponds to the public key contained in her digital signature certificate. A small detail to wrap the analysis of this signed email up is that the digital signature is transmitted as a PKCS7 digital signature, which is a recommended syntax of cryptographic messages and which has been known since 2009 as the cryptographic message syntax CMS as defined by RFC 5652. Let us now think back to the construction of the PKI and the certificate of Alice that was issued by the issuing CA1. The issuing CA1 actually added the URL of an OCSP endpoint to the certificate of Alice, which means that the validation of the signing certificate of Alice should include the use of OCSP to request the current validity status of the certificate. If the recording of Wireshark is now filtered for OCSP packages, the recording then clearly contains two such OCSP packages, where the first OCSP package is an OCSP request package sent from IP 192.168.121 to IP 192.168.120, which are the IP addresses of Bob and Alice, which makes clear that this OCSP request package was sent from Bob's machine to the machine of Alice, which is correct. As for the purpose of this demonstration, I had the OCSP responder of the issuing CA1 run on Alice's machine and configured the underlying DNS system to point the URL contained in the certificate of Alice to the machine of Alice. Drilling down into the OCSP request package, it's clear that this is an OCSP request package requesting the certificate validity status of a certificate with serial number 3BC7 and so forth when expressed as a hex string, and looking at the signing certificate of Alice, it's clear that the OCSP request is a request asking about the status of Alice's signing certificate. The second OCSP package listed is then an OCSP response package going now back from Alice's machine to Bob's machine. Drilling down into this OCSP response package, it's clear that this OCSP response package contains a response for the signing certificate of Alice and that the certificate status is marked as good. Overall, using OCSP was part of the certificate validation conducted by Bob's Thunderbird, which itself was part of Bob's Thunderbird verifying the digital signature on Alice's email, with this digital signature having all in all successfully been validated by Thunderbird, as was indicated by the icon and message provided by Bob's Thunderbird upon opening the email. In the last lesson of this chapter, I will demonstrate how Thunderbird reacts in case the signing certificate of Alice was revoked, but before we get there, I will demonstrate in the next lesson on how to use Bob's encryption certificate to finally protect the confidentiality of the emails exchanged.